given that x squared plus y squared is equal to 1, this is a circle, what is the greatest possible value of 2x plus 3y? So there are two ways that I think you could go about this question. One of them is quite slick, and the other is, I'd say also quite slick, but closer to what you do at A level, so closer to brute force, or the methods that you might have been more accustomed to. This question is actually quite similar to one at the University of Oxford in the mathematics admissions test a few years ago, where you had to find the maximum value of ax plus by. And so the idea here, especially for the slick one, is that a common technique that you use at uni is the fact that when you want to maximize something, and here we'd want to avoid differentiation, because if you try to rearrange y as the square root of 1 minus x squared, you'd have to differentiate. And at this point, you might not be able to differentiate that. So we automatically want to cross that off as an option. What we should notice is that 2x plus 3y, or a general ax plus by, should remind us of the general equation of a line. So we usually see lines as y equals mx plus c, but sometimes we see them written as ax plus by equals c. And so what we have is that we could have a line like this, or like that, like that. And then depending on how high up it goes, then that would determine the value that it's equal to. So here, when it passes through the origin, x and y are 0, so this must equal 0 at all points throughout its line. And so if we wanted to have a solution here, so we wanted our line to cross or at least meet the circle somewhere, the highest value we could go to is when this line is actually a tangent to the circle. So like that. So this 2x plus 3y line is a tangent to the circle. If we rearrange this, we know that y will be some function of minus 2/3 x plus here. And so what that means is if we were to connect a line to here to find our coordinates for x and y that we could put into our 2x plus 3y, we could see that our line here has a gradient of m equals 3 over 2. It's minus 1 over minus 2/3. And this line passes through the origin, so that means y equals 3 over 2x here. We could then substitute this into x squared plus y squared, so we've got x squared plus 3 over 2 squared, which is 9 over 4, x squared equals 1. We can multiply everything by 4, so we get 4x squared plus 9x squared, so that's 13x squared. And then this is equal to 4. And when we get x equals square root of 4 over 13, so that's 2 over square root of 13. If we put that into our expression, knowing that y is 3 over 2x, we have y equals 3 over root 13. So we've got 2 times 2 is 4, 3 times 3 is 9. We have 4 plus 9 over root 13 using the 2x plus 3y expression. This gives us 13 over root 13, which is just root 13. So the answer is G. So this uses a common skill of dragging out a line until it's tangential to the surface or constraining function that you're dealing with. But this might not have been natural to most of you, or at least if you did identify it, it's quite straightforward. Well, not necessarily straightforward, but if you did identify it, you could see a path from there. But I think the most natural way for A-level students to have attempted this question is to say, well, 2x plus 3y could equal some maximum value. And I'll call this maximum value m. And we know that our function that this must satisfy, or this expression this must satisfy, is x squared plus y squared equals 1. So we need to think of, if m gets larger and larger, that might mean that the values of x and y that solve this might not necessarily be able to solve this x squared plus y squared is equal to 1. So if I were to substitute our y here, this would be x squared plus a third of m minus 2x squared, and this is equal to 1. And why this might be more natural is because now I've got a quadratic expression which, when I expand and bring everything to one side, I could then use a common technique in A levels, which is using the discriminant. So this is what might have inspired, or is most likely to be identified by some students. So using or manipulating quadratic expressions in order to find some inequalities. Because whenever you see something that says greatest possible value or maximization, you either think complete the square, you either think to maybe differentiate something, or you can see how you can manipulate any of the values you have to see what's constraining you. Because whenever we're looking at maximization problems or minimization or optimization in general, we want to see what's constraining us. And so when is one factor, being outweighed by another and so forth. But here, let's proceed. We have x squared plus 1 over 9, a third squared. Then we have m squared minus 2 times 2, so that's 4mx, and then plus 4x squared. This is equal to 1. If we multiply everything by 9 and then carry things over, we have 9x squared and then 4x squared. This will be 13x squared. Then we would have had the minus 4mx. And then we would have had the m squared here, and then 9 times 1 on the other side, and then taken over is minus 9. It's equal to 0. And now we know for this to have a solution, the discriminant must be greater than or equal to 0. So we have b squared, which is 16m squared, minus 4 times 13, which is 52, times m squared minus 9, must be greater than equal to 0. Rearranging this, 52 and 16, we get minus 36. So we get 36m squared on here. And then we have 52 times 9. Remembering not to really multiply stuff, because if you can see cancellations later, this can help. So if I divide by 36, I know 9 over 36 is a quarter. This is 52 over 4. M squared. So 13 is greater than or equal to m squared. So m, given that we're looking for the maximum value, m is less than or equal to root 13. So the answer is root 13, as highlighted by the previous method. Hopefully these make sense, but if you do have any question, please do let me know.